So, you've probably heard all the buzz about this new wave of AI. You know, the ones that claim they can actually think and reason their way through a problem before giving you an answer? Well, a groundbreaking new paper just dropped from researchers at Apple, and they decided to put that claim to the ultimate test. And let me tell you, what they found is absolutely fascinating. And honestly, more than a little surprising. So, let's dive in and see what they actually discovered. This is the big question, isn't it? I mean, for years, we've watched AIs get incredible at language, but real, honest to goodness reasoning, the kind of flexible thinking we use to solve a puzzle we've never seen before, that's always been the holy grail. So the question is, have these new models finally cracked the code? All right, so meet the new kids on the block, large reasoning models, or LRMs. We're talking about models like OpenAI's FA1 or the thinking version of Cloud 3.7. Now, their special trick is that they don't just spit out an answer. No, they generate this long, detailed chain of thought, kind of like an internal monologue, where they explore ideas, backtrack, and reason through the problem. It's just like your high school math teacher telling you to show your work. The whole idea is that this makes them way smarter and more reliable. Okay, but that brings up a really important question. How do we actually know if this thinking is the real deal? The researchers behind this paper argue that our standard tests, grabbing math problems off the internet, they just don't cut it. So they came up with a much, much better way to put these AIs under the microscope. See, the old way of testing has this massive flaw called data contamination. The AI might have already seen the exact problem or something super similar in its training data. It's basically like giving a student a test when you know they've already peeked at the answer key. So the researcher's solution was brilliant. Use custom-built puzzles that the AI has never, ever seen before. This way, there's no cheating, and this is crucial, they can crank up the difficulty step by step to find the exact point where the AI's reasoning breaks down. And we're not talking about just any old puzzles. They picked 4 absolute classics from computer science, and each one tests a totally different kind of logical skill. You've got the crazy recursive planning of the Tower of Hanoi, the complex rules of the river crossing puzzle. These things are designed to be easy to understand but get incredibly hard really fast. This is basically the ultimate AI Olympics for reasoning. So the tests are set, the AIs are ready to go. And right out of the gate, the very first result is a total shocker. I think we all just assumed that an AI that thinks would always be better than one that doesn't. Well, it turns out that's not true. Not at all. The researchers found 3 totally distinct zones of performance. First, for the easy, low-complexity problems, the standard, non-thinking models were actually better. Yep, more accurate and faster. It's only in that middle zone with medium complexity that the thinking models, the LLRMs, finally show why they exist and pull ahead. But then you get to the third zone, high complexity. And here, something really dramatic happens. Both types of models just fail. Their performance completely collapses to 0. And this chart just tells the story perfectly. You can see the thinking model's accuracy is great for low complexity, and it's still pretty strong in the middle there. But just look at what happens at high complexity. Performance just dives off a cliff. It shows that this thinking ability, it's not some magic bullet. It really only works inside this surprisingly narrow window. And once you're outside that window, it completely falls apart. Now, this collapse at high complexity, that's the real mystery. Why do these incredibly powerful models, literally designed for reasoning, suddenly just fall to pieces when the going gets tough? Well, the answer the researchers found is deeply counterintuitive, and it reveals a fundamental limit to how these AIs actually work. Okay, you have to let this one sink in for a second. When you're faced with a really, really hard problem, you'd expect the AI to try harder, right? To generate a longer, more detailed thought process. But it does the exact opposite. As the problems get harder, the models actually reduce their reasoning effort. They start to think less. And the data just lays it all out there. As you go from medium to high complexity problems, the reasoning effort, the amount of thinking it's doing, it goes up just like you think. But then it hits a wall. And at the highest complexity, the model's effort suddenly just drops. It's like it gives up, even though it has plenty of capacity to keep thinking. It's a baffling and pretty critical limitation. As the researchers put it in the paper, this isn't just some weird quirk. It points to a fundamental limitation. Basically, what they're saying is, it doesn't matter how you prompt them or how big their budget is to think, there seems to be a hard ceiling on the complexity they can handle, a point where their whole reasoning process just starts to break down and retreat. And get this, even when they are thinking, the whole process is incredibly inefficient. For easy problems, the models often find the right answer almost right away, but then they spend thousands of extra tokens just exploring dead ends. The researchers call it overthinking. It's like solving a Rubik's Cube on your first try and then just continuing to twist it for another 10 minutes. It makes no sense. Okay, so we know these models struggle to find a solution on their own, but this is where it gets really wild. What if you just took that part out of the equation? What if you literally handed the AI the answer key, the perfect step-by-step algorithm to solve the puzzle, and just asked it to follow the instructions? I mean, surely it can't fail then, right? Nope, wrong again. Unbelievably, even when they are given the explicit, perfect algorithm, the models still fail at the exact same complexity point. This is a jaw-dropping result. It means the failure isn't just about problem solving, it's a fundamental inability to execute a long sequence of precise, logical steps. It's like having a perfect recipe, but being physically unable to follow it past step 5. And what's even crazier is how inconsistent their reasoning is. For a hard Tower of Hanoi puzzle that needs over 1,000 steps, the AI can actually make about 100 correct moves before it fails. I mean, that's pretty impressive. But then for the much simpler river crossing puzzle, which only has 11 total moves, it makes a mistake by the 4th step. This really suggests its success isn't about pure logic, but about pattern matching. It's just seen the Tower of Hanoi more in its training data. So when you put all these pieces together, you've got the 3 regimes, the scaling limits, the inefficiency, the fact that it can't even follow instructions. It forces us to step back and ask a really tough question about what's actually going on inside these things. So what's the bottom line here? It means these new thinking AIs have very real and, frankly, very surprising limits. Their thought process is messy, it's inefficient, they're actually bad at the simple task of just following instructions. And a lot of their success might just be coming from recognizing old patterns, not from a true general ability to reason. And all of this leads to one final critical question. Are we actually building models that are learning to think? Or are they just becoming incredibly elaborate illusionists, creating a very convincing performance that completely falls apart the second they face a truly new challenge? This research doesn't give us the final answer, but boy, does it give us a much sharper way to ask the question. Thanks for tuning in.